Sometimes you just want to reduce everything down to 0 and start over. Can we do that with a matrix? Well, we can, with the help of a little something called the additive inverse. To understand the additive inverse in matrices, first we will look at the concept with simple numbers. Let's take 7. I want you to add something to it that will give back the additive identity. I mean 0. What would it be? Obviously, the negative of 7, because only 7 minus 7 gives you 0. This negative 7 is called the additive inverse of 7, and it can also go vice versa. Moving on to matrices. If you have a matrix A and adding a matrix B into it gives you the additive identity, which was the 0 matrix, then this B is called an additive inverse of A. Or we can say that A is the additive inverse of B. Mathematically, we write it like this. Let's take a 3 by 3 matrix to understand this further. I'm labeling it as A. Now what? Where will we get matrix B from? For the number 7, we took the negative of 7. So, quite similarly for A, we will take the negative of A and call it B. So, to get matrix B, multiply the whole matrix A by negative 1. Do that or simply change the sign of all the non-zero entries. Hence, all these positive entries, that is 1, 2, 1, 3 and 1 becomes negative. Whereas, these negative 1 and 2 becomes positive. This new matrix B below A is now a negative of matrix A and is called the additive inverse of A. Thus, for this relation, matrix B will be the same as matrix A in all aspects except one, the signs of its entries. Let's verify it by finding A plus B. You see, every number is added to its inverse, giving you a 0. And here you go. The result is a null matrix O full of zeros. Leave that on your screen and below it, do it once more through the other way. And you will see it happening again. This is simply because all the elements are being added to their negatives. The additive inverse acts like the Ctrl-Z command from Windows. It undoes everything and you end up with a 0. Because A plus B and B plus A both give O, therefore, we can say that A and B are the additive inverses of each other. To recap, we already know that we can find the negative of any matrix. The matrix and the negative are the additive inverses of each other because their addition dramatically eliminates everything to give a matrix full of zeros. Of course, the additive inverse is not the only type of inverse. You also have the multiplicative inverse, which is really important. But you'll have to wait until the relevant lesson to find out about that.